this video, we'll create a UI widget that can be used for things like nodes and skill trees, and we'll make it entirely material-based to make it as scalable and performant as possible. So the first thing we're gonna do is get the UI Material Lab. You're gonna go to the Epic Games Launcher Marketplace tab, type in UI Material Lab. If you're not familiar with what this is, it's a tool set which can take your UI to the next level very easily. If you wanna learn how to use this in more detail, there is a YouTube video by the senior technical UI designer at Epic Games, which is very easy to follow along, very understandable, that explains how to use this tool set. And if you're like me, once you start using it, you're never gonna stop. Essentially what we'll do in this video is look at one way that we can use this tool set to build something awesome. So what you're gonna do is create project, open up the UI Material Lab project that you just created, right click, migrate everything to the content folder of the project that we'll be working in. And now here in our project, you can see it's been migrated here, UI Material Lab. So what we're gonna do first is we're gonna expand the Skill Tree Pro folder, and we're gonna right click, new folder, create a materials folder. Basically all the work that we'll do in this video will be inside of the material. Other than that, we're just going to create a node that we assign the material to. So first let's create the material. So we'll right click material, we'll call it m_node, and then we'll right click on that and create material instance. mNode instance is fine. Now we're gonna go down here to our widgets folder and we're gonna create the node widget. So we'll right click, go down to user interface, widget blueprint, and we'll make it a user widget and we'll call it WBP_skill tree node. Let's open up our skill tree node. And our node's going to be a canvas panel with an overlay dragged onto the canvas panel and also a text dragged onto the canvas panel. And we're going to drag two images onto the overlay. We can name the two images background and icon. And we're going to make the background a variable, the icon a variable, and the text a variable. For the overlay, we'll set the anchor to center, zero it out, alignment 0.5, size to content. For the background, we're going to fill horizontally and vertically, expand the brush, and in the image, we're going to use that mNode instance that we created. We can go ahead and change the material domain. In the icon, we'll also fill horizontally and vertically. Open up the size and we'll make it 128 by 128. And for the text, we'll set the anchors to the bottom, center it out. And before we go any further, let's go to custom 200. And this will give us a better idea of what it'll look like. We can set the size to 0, alignment 0.50, and we'll scroll down and center the justification. And if we want, we can F2 here and just change the name to text. And the last thing we'll do is click on the overlay and make it hit test visible, because we always want this to react whenever we click anywhere in this overlay. So now that we've created our node widget, we'll add a few to our skill tree so that we can fire up the game and test out our updates and see them visually as we're modifying this background material. And then once we add a few to the skill tree, we'll spend the rest of the time making this material. So let's close the skill tree node and open up the WBP skill tree. Now we'll come up here and just type in node, and we'll add that WBP skill tree node just somewhere on the node's canvas. Size to content, and just drag it around somewhere. And if you want, you can duplicate it a couple times just to kind of get a feel for what nodes will look like on here. And don't forget to select all and center the anchor. And then when we fire it up, you can just see we have some nodes here. So now we can close this and come into the materials folder and open up the base node material. The first thing we'll do is come over here to material domain and change it to user interface, because we're going to be using this material only for UI elements. And we'll change the blend mode to translucent because we want to be able to partially see through it. And we're going to begin designing this material by creating a circle from one of the functions in the UI Material Lab. So if you right click and type MFUI, this is the prefix of all of the functions in the Material Lab. We're going to scroll down here and choose MFUI SDF circle. If you're not yet familiar with SDFs, this is a very performant way to create a shape in a material instead of using a texture. You create a shape from math. If you click on it, you can look inside. And if we right click, start previewing, you can see it creates a circle shape. So what we're going to do is drag off the SDF output and add a named reroute. Call it circle SDF. And we'll plug a text chord into the UVs and hold 1 on the keyboard, left click to create a constant. Make it 0.2 and that will go into size. And we'll right click and create parameter, promote to parameter for glow min and the same for glow max. And we'll set glow max to a default of 0.2. And we'll comment this SDF circle. And we'll click on this arrow here to see what it looks like. Now earlier I said an SDF creates a shape, and that's not quite accurate. It actually creates a gradient which goes from +1 in the far exterior to -1 in the center. And this entire black area is negative values. It looks black because you can't see the negative values visually on here, but it's 0 around the outside of the circle, which goes to -1 to the center. So what we need to do here is create a shape from the SDF, and we're going to use that shape as the background shape of the node itself. So we'll take that circle SDF, put it into the value input of a smooth step, and we'll go from 0 to 0.01, and then we'll do a 1 minus, and we'll create another named reroute called shape. And now if we look at it, what we've done is create a shape from that SDF. So we'll comment this, we'll call it final shape. Now over here, we can just plug shape into the opacity and promote final color to a parameter. And let's make it white and raise the alpha all the way. And click apply, and over here, we can see our final shape. A nice smooth circle. Now if we fire up the game and open the skill tree, we can see a nice smooth circle as a background for those node widgets that we've created. So we're on our way. Now doing it this way has a couple big advantages over doing it with a circle texture. For one thing, if you use a circle texture, the edge of the circle is never going to be perfectly smooth unless you have a very, very high resolution texture. And even still, if you scroll in far enough, it's not going to be perfectly smooth. And the other big advantage to doing it this way is that this requires absolutely no texture memory, which is normally the bottleneck. You're running everything off of the shader code, which is run off the GPU, which is orders of magnitude faster. So doing it this way is just much more performant. Now, at the beginning, we said we were going to make a versatile UI material, and we don't always necessarily want a circle. We might want the nodes to be in the shape of a square or a triangle or something else. Well, it just so happens if we right-click and type SDF, you can see there are SDFs for many shapes here. So we're going to add a few more in and then lerp between them as a choice in the material instance. Just for organizational purposes, we're going to drag these over here and create some named reroutes. This will be called scale, glow min, glow max. Hold 1, left click. Right click it, convert to parameter, and this one will also add a corner roundness and make a named reroute for that. Corner roundness, and we'll comment this SDF parameters. And we can add the reroutes back in here. And now we can use these reroutes for all of the other SDFs that we create and just keep it nice and tidy. And we'll also put this text chord into its own named reroute. Call it UVs. Create a triangle SDF. Drag off the SDF output. Named reroute. Call it triangle SDF. Copy and paste these inputs. And we're going to do something a little different for scale. We're going to hold L and left click, input the lerp into the radius, put scale into A, M left click, put the multiply into B, and multiply by 1.5. And into the alpha, we'll put the corner roundness. And the reason we're doing this is because corner roundness increasing tends to shrink the size of a triangle SDF, so this negates that effect. I'm going to copy corner roundness down here, and we'll divide by 5 and plug that into the corner roundness. And we can call that SDF triangle. Now we'll do the box, choose MFUI SDF box, the SDF output, make a name to reroute, box SDF. We'll copy these, paste them down here. UVs, scale, glow min, glow max, copy corner roundness divided by 5 and plug it in. Comment this, call it SDF box. And the last one, we'll do the SDF hexagon, drag off the SDF, make a name to reroute, hexagon SDF, and we'll just copy all of these. And we're going to remove the divide in this one, so it's just the corner roundness, and we'll drag that up here, plug it into the corner roundness, UVs, radius, glow min, glow max. And the reason we're not dividing this corner roundness by 5 like the two above is because the way the SDF math works in the different functions, these values tend to create the same corner roundness with the different shapes. So we'll call this SDF hexagon. And now that we have our different shapes, we're going to set up some parameters to be able to choose the shape that we want in the material instance. So we'll get the circle SDF and the triangle SDF, L left click, and lerp between the two. We'll promote this to a parameter, and we'll call it isTriangle ? And over here, we'll change the slider max to 1. And we'll make the group shape, and we're gonna lerp 2 more times, L left click, L left click. We'll put this lerp into A and box into B. We'll promote to parameter isBox, and do the same for this parameter. And we'll drag this output into A, and hexagon into B. isHexagon. Slider max 1, group shape, and off of that, we'll create a new named reroute and just call it SDF. And we can comment this and say, which shape are we using? And the last thing we need to do is remove this circle SDF and put in our general SDF into the value here. Apply, and if we come over to the material instance here, go under shape, enable these, and maybe zoom in a little bit. And when we slide the box up, you'll see that the circle just morphs into a box. So we could even have like a half circle, half box, or, you know, something between the various shapes that we think is interesting. And now if we fire up the game, we can see our new shape has been created. Let's comment this whole thing SDFs. Now, it's very common for a node sort of UI element to have a border. We could use an image for the border, but why do that when we can just do some math on the SDF and save the texture memory? So what we'll do to create the border is we'll get the SDF and we'll get its absolute value. And now if we look at it, it goes like this, because remember, it goes from 1 here to 0 to -1. And now we need to find a way to turn this gradient into something crisp, like a border. So for that, we're going to use the smooth step node. Plug this into the value, 1 left click, convert to parameter, call it border thickness, make it a default of 0.02, and we'll subtract 0.02 from that. And before we plug it in, we're going to saturate. And what saturate does is it simply clamps a value between 0 and 1. And the reason we use saturate instead of clamp is because saturate's free on most modern hardware. So we'll saturate both of these. And we'll plug this into min and this into max. And now if we look at the result, we have a nice crisp border. However, we need to invert it, so we'll do a 1-. And now we have what we're looking for. Let's make a name to reroute here and just call it outline. And we can call this border. And now we just need to add the outline into the final output. So instead of shape going into opacity, we'll get the outline and we'll do a max between shape and outline and plug that into opacity. And what this does is it gets the max value for every pixel. So it'll show the entire shape and the entire outline. And they're both white, so we can't see it. So to see the difference, let's change this name from final color to center tint. And let's do a color lerp. Center tint in B, we'll copy paste this up here. We'll call this one border tint in A. And for the alpha, we can just get the shape. And now if we zoom in here and change the border tint to something else, we can see the border surrounding our shape. And to really see the difference, we can go into our instance and change the border thickness to whatever we want. And now if we fire up the game, we can see we have something that's looking a little bit more now like skill tree nodes. Now it's very common with this kind of UI element to have there be a space between the center part and the border. And so we want to have control over that. So that's pretty easy to add. Instead of plugging this SDF directly into the absolute, we'll subtract, plugging that into the absolute, a lerp, and we'll promote this to variable and call it border start. And promote B to variable, call it border end. We'll give border end a default of 0.1, and now you can see the space. And we will promote the alpha to something we call border distance and give that a default of maybe 0.5. And we can also control the crispness of this border and or how much it sort of fades out by multiplying this by a radial gradient. So we'll go multiply, plug it into the outline, and here we'll type radial gradient exponential. And we'll promote the radius to a parameter and call it border fade distance. Give it a default of 0.3. And we'll promote the density to a parameter and call it border fade density. And give this a default of 1. Now you can see it's a bit more faded. And let's select all the, just shift drag on all of the border parameters we've created, including this one up here. And we can just create a group from them, call it border, and we'll apply. And now in our instance, under the border category, we have a lot of different parameters to play with. And just like we added these parameters into the border category, we can add these into a center category. So we'll select glow min, glow max, corner roundness, and over here, control left click on center tint. And we can just put them all into a center category here, apply. There it is. And it's also very common for a UI element like this to have a glow. For example, if you just learned it, it might, radiate this kind of glow. So we also need to add a highlight to this. So to do that, we'll take the SDF, we'll add one and left click, convert to parameter, highlight size, we'll invert it, 1 minus, and then we'll invert it again. We'll get the power. This is a more expensive node, so we use it sparingly. We'll promote to parameter, highlight compactness, saturate to clamp between 0 and 1, and make a name to reroute and just call it highlight. And we can comment that, call it highlight. And now we just need to add that into our final output. So we can add another max node down here with highlight and plug that into opacity instead. So now we're getting the max of everything. And we can copy, paste this, call it highlight tint, do another lerp here, plug that into A, plug border tint into B, plug the output into this lerp, and in the alpha, get the outline. Select the highlight tint, control left click, highlight compactness, highlight size, put them all into the highlight category, apply. We can go back to the component and just change the zoom clamps. Zoom in clamp can be something like 3. And now you can spend some time playing with the parameters and get something that you like. And the shape of the border and the highlight move with the center because it's all based on the same SDF. And if you fire up the game, you can see it here. And now we have something that looks a bit more like a node on a skill tree. Now another piece of functionality we could add to this UI element is the ability to rotate the shape. Let's say, for example, we want a diamond instead of a square. We could achieve that by just rotating this shape 45 degrees. So rotation is a pretty common thing to have with this sort of UI element. So to achieve that, we can come over here to the text chord, and instead of just having the text chord pumping directly into the UVs, we can input it into a custom rotator and put that into the UVs. And we can set the center of rotation to 0.5, which is the center, so nothing changes there. And we can parameterize the rotation angle. And we can set the slider max to 1, create a new category for it, call it general, apply. And now when we come over here to the instance, now we can rotate the shape. So if I want a diamond, 0.125. So now what we've done here is we've set up the ability to give it a static rotation, but what we can also do is set up the option to give it a dynamic rotation, meaning that it keeps rotating whenever the UI is open. And the way we can do that, we can take the time input, left click, multiply that by a new parameter, and call this rotation speed. And we can set the slider min to -1 to 1, and put it in the general category. And we can add this to our static rotation. And to make it compatible with this rotation angle input, we can take its fraction and give it a 1 minus x. And now when we come over here to the instance, enable rotation speed, set it to 1, maybe something a bit slower, 0.2. And we have this nice constant rotation, which also works in the game, as you can see. Now the UI element's rotating, and it's all being done in the material. So this rotation animation is in the material. And one very important thing that I want to point out here, a limitation of doing it this way, is that you cannot change this parameter, rotation speed, dynamically. Meaning during the gameplay, when the UI is open, you can't change it dynamically. You can with all the other parameters, but not this one. Because as you see, if we drag it, it freaks out. And the reason it freaks out is because it's based on, if you go back here, it's based on time. And when you're multiplying game time, which is a huge number in and of itself, by any change in fraction, it's going to be a hugely different result. So the one limitation of this parameter is that this rotation speed stays constant. And the reason I'm mentioning that is because we're going to extend this system later to dynamically change all of these parameters according to the state that the node is in. So let's make a little note here. This value cannot smoothly lerp, so keep it consistent. And we'll comment this, we'll call it, rotated UVs. Now another common piece of functionality that UI elements like this often have is some kind of animation on the border, this line going around it. Maybe it goes out and fades out into the distance, or it goes out and it comes back in and keeps ping-ponging between those two results to signify maybe that it's been selected. And we can do that in much the same way that we did the previous piece of functionality. So what we'll do now is we'll come over here next to the final shape, and we'll search for the Material Lab function, MFUI linear time. And we're going to do something slightly fancier this time, but not too much fancier. We're just going to double click on it, and we're going to come over here to Browse. And we're going to find it in the content browser here, and the reason we're doing this is because we want to select it, Control D, to duplicate to create our own. And we're going to slightly modify it. I don't want to modify the original. We want to keep that functionality in case we want to use it. MFUI my time. And we'll drag the one that we've created up into our materials folder. Move here. And then we'll open it. And you can close the other one. And also back in here, we can delete the other one. That was just to find it very lazily. And now in this material function, we're going to change just a couple small things. We're going to right-click Input, Function Input. We're just going to create one more input. We're going to come over here and make it a function input scalar, and we'll call it base value. And we'll click Use Preview Value as default, and we'll left-click here, and we'll just put in an input of 0. Drag off here, do a name to reroute, call it base value. And we're simply going to add this base value to the outputs just by popping it in after the time input and adding it there. So here we can left click, to add the base value. And we'll just copy paste, do the same for these two. And all this does is make this compatible with the static rotation by allowing us to input the static rotation. So if we apply and come back here and get our new function, we have two outputs here that do two different things. Loop just brings it from 0 to 1, so this will cause a result of the border animation kind of moving out, fading into the distance, and then starting back at the beginning and doing the same thing. And the ping pong output will bring it out and bring it back in, bring it out and bring it back in. So we want both of these pieces of functionality. So one way we can select between them is with a lerp, and we could promote this to a parameter and just call it border anim ping pong question mark, and maybe make it the default to ping pong and select it, and down here slider max 1 category border, and maybe the description so we remember 0 equals no, 1 equals yes. And then we'll just say don't choose value in the middle. It's got to be 0 or 1. We could make this a static bool as well. And what we'll do here is we'll make a named reroute. Let's call it border animation. And now down here where we have border distance, we're going to bring border distance up here, and we're going to input border animation down here. And one thing we forgot to do when we changed this is delete this input float value scalar. Yes, and just hook it right up here. Apply. And so now we'll input the border distance into the base value, and we'll create a new parameter here, call it border anim speed. Down here we can make the slider max 1, group border, and just like before, this parameter must stay consistent because it's an animation done in the material. So we'll paste in the description from earlier, this value cannot smoothly lerp, so keep it consistent. Here we can comment this and just call it border animation. And click apply, and if you come over to the instance and change the border, enable the border anim speed and change a couple of the parameters, you can see that we have this nice animated border that kind of fades out into the distance. And if you play around with the border start and the border end specifically, you can control where it starts and ends. And you could enable the ping pong to bring it back like this. And so now we have some nice animation options with this UI element as well, which are all done in the material. Now another piece of functionality we might want to give this UI element is just a general opacity slider. And we might want that because, let's say for example, the skill that this node is representing is unlearnable. We might want the skills in those states to be slightly less opaque. So what we'll do is we'll come back over here and we'll go to the opacity input, and we'll simply multiply the final result, M left click, by a new parameter, call it opacity. Set the default to 1. Down here slider max 1, category general. And we could comment this and just call it final opacity. Apply. Now we have our opacity slider. We can fade the whole thing in and out. Now the last piece of functionality that we might want to add to a UI element like this is the ability to make the center part a little more variant and interesting. Right now it looks kind of flat, so what we could do is we could make a gradient based off of the SDF. To do that, we can come over here, and instead of the center tint piping directly into B, we can lerp that with the center tint multiplied by the SDF, taking the absolute value of that SDF. We'll saturate it to clamp it, and we'll create a parameter to control it, and we'll call it gradient. We can make the slider max 1, put it in the center category, and we'll just select and call this final color. Apply, and now over here we can give the middle a gradient, a full gradient, or anything in between to make it kind of interesting. And now we have a really diverse, customizable background for a node, for a skill tree that can look pretty much any way that we can imagine, and it's all done in the material, which means it's very performant. So now that we've got our nodes designed, in the next video we're going to create a way to generate them procedurally as a tree of nodes. Our entire skill tree will be procedurally generated, yet we'll still have a high degree of artistic control over the way the tree gets generated.